Good evening. My name is Jakani Cole, and my presentation is on malaria. So, to give a background on malaria, um, it was referred to back then as the king of diseases back in 270 BC, and old Egyptian medical texts can date it back to about 3200 BC. Mesopotamian scripts describe it as deadly fevers. It became much more widespread once it spread from the Nile River, and evidence for malaria parasites have been found in fossilized mosquitoes and can be dated back to about 30 million years. So when it comes to identifying malaria, the obvious thing, of course, is the high fever. Like I said, even back then they referred to it as a deadly fever, and that's still one of the main symptoms now. Um, it can be identified by a low red blood cell count because it also causes a lack of oxygen supply to the bodily tissues. And it can be also identified from a blood test. So things can get pretty dire, for someone who has malaria. It can be life-threatening if you're infected with it. Some of the other symptoms outside the high fever include headaches, sweats, chills, muscle aches and pains, diarrhea, vomiting. It takes about 2 weeks to cure if it's treated right, but it can linger if it's not treated. Like it can linger for years. And there are anti-malarial medications to help treat the disease as well. Something you might be wondering about is just how much damage malaria does on a year-to-year basis. And I was able to gather some data from the year 2023. So there were over 263 million cases of malaria, and it caused over 600,000 deaths. 94% of those deaths, though, alone came from Africa. And about three-fourths of those deaths came from children ages 5 and under. So to get more specific, malaria is a parasite, and there are 6 different species of that parasite that cause malaria in humans. Only 2 of those 6 have been researched adequately, and then there's another one that is pretty active, specifically in Southeast Asia. So a few ways that malaria can affect your behavior is so once someone does contract malaria, it does affect your behaviors too. Malaria has been associated with things such as confusion, disorientation, having a hard time concentrating, being more irritable, seizures, hallucinations, comas, etc. Right? Most of this is caused by the parasite, getting into your brain, affecting the brain cells. So it can cause a lot of discombobulation. So the areas that malaria hits the hardest in, outside of Africa, obviously, is Asia, Central America, South America. And specifically, people who work outdoor jobs are going to be at a higher risk because, it is spread by mosquitoes. And so, if you're outdoors, you're going to be more likely to be bit by a mosquito. And it can affect education too, because like I said, it can affect brain function, and it's going to be a lot worse in children too, maybe even cause anemia. Malaria does seem to be a more common thing in the more humid times of the year. Specifically in Senegal, it was transmitted the most during the end of the rainy season. There is an interesting hypothesis, or some may even call it a theory, when it comes to malaria. And what this hypothesis is implying is that malaria has caused this type of genetic mutation or evolution, if you will, right? So sickle cell. So like when it comes to, if someone has sickle cell and they can't contract malaria, and the reason why is because the cells will quote unquote sickle before the malaria has a chance to spread. And they feel like the reason why it even developed was as a defense mechanism to malaria. So as people in those, heavily populated areas with people that were having malaria, especially in Africa, when they were, reproducing, these kids were being born with sickle cell, and it really came from the body trying to protect itself from malaria, and I guess even overcompensating in a way. So there are a few things that need to be researched a little more on malaria, a couple of knowledge gaps, because there were technical limitations early on, because malaria can date back to over 32 million years. So there's a lot that we still don't know. So some of the knowledge gaps include like the fundamental biology of malaria, how it would respond to chemotherapy, and some suggestions for further research might include a deeper dive on all of the variants and a better vaccine for the disease, or a vaccine period. Um, and one of the biggest necessities is to find an answer for the VVAX parasite specifically, because that's the one that seems to run the most rampant.